Okay, hi everyone. Welcome to AAS Tech Talk Part 4. Today we're going to be talking about Stripe and webhooks. So, I want to start with what is a webhook. So, a webhook is just an API endpoint. It's intended for use for other services to be able to talk to your app. So, if you remember in our app so far, we've set up a bunch of orders endpoints. So, for posting, getting, and putting to create, update, delete, and order. We set all these up in our router. How you'd set up a webhook is just the same thing. You would specify some endpoint. So right here we have /webhook that some service could talk to. So if you're going to have Stripe talk to your service, you'd set up a /Stripe endpoint and tell Stripe to talk to yourwebsite.com/Stripe or however you have it set up. And that allows Stripe to send your app messages. So in case that wasn't clear, here's another kind of graphic that talks about it. If you remember, our router is where we define our routes. So our /order, /ID, the post, the get, all that stuff that we wrote in the code, that's our router. And if we specify places where other services can talk to ours, that's called a webhook. So webhook use cases are notifying your app of changes in other services that you use. So if you use Stripe for payment processing, if you use a customer management system, if you use any other service, a webhook is a really useful way that you can be updated of problems, of anytime you get updated, of when you get paid, of when a customer changes their data. This is really a better way to do what was done in the past, where you would have to continually reach out to the other server and say, hey, have I gotten paid yet? Have I gotten paid yet? Continually over and over. Webhooks flips it and lets the service talk to us and tell us when things have been changed and when we need to be aware of that. So Stripe is what we're going to be using today to set up payments. We aren't going to be setting up a Stripe webhook, but I will go through and show you how it would be done, just because we don't really have a need to set it up for our application. Webhooks are more used in a case where there's a subscription or something where you're going to need to have a longer period of time where you'll be listening for events. So Stripe is a payment processor. It's kind of the preferred payment processor these days. PayPal's Braintree is another big one, but Stripe is kind of come out as the front runner as far as developer support and making it easy to set up. And you'll see why in a minute. The Pizzilla integration, what we're going to do is we're going to make it look like this. So if you remember our Pizzilla app, we can choose our toppings up here on the top, and then give them an option to pay with their card or start over. And then once they click pay with card, this will pop up. So it'll pop up, it'll let them put their email in and their card number, and they'll hit pay. So how Stripe works, we'll go through this in detail setting it up, but just so you have a high level overview, there are two keys for your Stripe account. So there's a public key and a secret key. How it works is you put the public key in your browser, so in your app, and when they click pay with card, that little thing will pop up, and they'll put in their card number, and using that public key, Stripe will send their credit card information and your public key to Stripe's servers, and it'll send your app back a token. So this is all part of PCI compliance. So using Stripe, our website doesn't need to be PCI compliant. The PCI compliance is what does that stand for? Payment Card Industry Security Standard. So you do not need, your website or your server does not need to be set up to receive payments. All it needs to have is these two keys, and Stripe manages all that for you. So we're never sending the user's credit card information to our servers. Stripe will send us a token that we can reference. So that token has their credit card information inside of it. So once we get that token back from Stripe, we'll then send that token to our server and use the secret key along with the token to generate what's called a charge in Stripe. So that secret key we keep only on our server, and we use that to kind of manage our account and do things on our account. Our public key is only used to really generate tokens and tell Stripe what app is sending those requests. So if you haven't already, go and create a Stripe account. It just takes a minute, and then come back here and we will get into creating, we'll get into setting up the app. So let's switch over here to our, here we go, to our app. We can see we have our API and our Pizzilla React folder. So first thing, let's set up our React app so that it has the stuff that we need for our for Stripe. So we'll go to our components folder and we'll open up our order page. So our order page, if you remember, let me open up a terminal here and start our API and our React app so we can see what those look like. So we'll do cd Pizzilla React and npm start. Okay, and that will come up there. We'll put this on this other desktop here. And then we'll open up a new server or new terminal, and we will do cd API to get into our API folder, and then we will do node app.js to start running. And we can see Pizzilla API is running on port 3001. So if we come back over here to our app and we put in our name, we can see that it is running. So what we want to do is we want to change out this order pizza button for a Stripe button. So let's go ahead and just look here. So let's do React Stripe checkout. Just Google this. And the first thing that comes up is an NPM package that some nice man has put together for us. The React Stripe checkout component gets 20,000 weekly downloads. And what this does is it just helps us package up the entire Stripe checkout into one nice package. And so what we'll do is we'll copy this. We'll come back over to our React app. We'll stop it temporarily and then type npm-i for npm install React Stripe checkout. Let me see if I can make this a little bit bigger. Okay, npm-i React Stripe checkout, and we're just going to type -- save at the end so that it saves it into our app for future use. So we'll let that run for a second. And let's switch back over here while that's installing and look at what this is going to do for us. So how this works is here we have the component. So we're going to import it here at the top. And then we have this component that we just drop in. We put this public key in. So here we need to get our key. And then we have a function that will be called when we get our token back. So remember, Stripe will take our key. They click on this button. A thing pops up, asks them for their credit card information. Then once that's done, it'll send it to Stripe and send us back a token. And it will call this onToken function when they get that. So let's set this up. So first we'll copy this Stripe checkout import. We'll come up here to the top of our page and just import that. The next thing we want to do is get this Stripe checkout component. And let's just put that right. We'll scroll down here. Let's put it right above our order pizza, our current order pizza button. So we just can see what it looks like here. And let's switch back over to our app. Oh, we need to start our React server. So do npm start again in the terminal, and it should bring that up. So it says cannot read property on token of undefined. So what we need to do before we can run that, we told it to look for the on token function, and we haven't put that in there yet. So we'll copy this on token function. One important thing we need to understand or realize is this is inside of a class component, which means that they're using the this binding to talk about the class component, to talk about inside this class. We are using a functional component. So you can see right here, we just have function order page, whereas they have class take money extends React component. These are just two different kind of architectures that you can use in React. We're using the functional one. So we are going to change this to not say this dot right here. We're going to change this to not say this dot on token. We're just going to delete it to say on token because we don't need the this. And after submit pizza function, we'll stick this in here. We'll just change this a little bit to be function on token. We'll take out this as well. So function on token, and it's going to run this. And we'll be changing this as well a little bit. So let's come over here. Okay, we see that this runs, but we have a pop-up. It says Stripe checkout can't communicate with our payment processor because the API key is invalid. So that is because we did not put our key in yet. So what we need to do is pull up your Stripe dashboard. Yeah, so I'm going to pull up mine. So click dashboard. It'll pull it in. Click view test data, this toggle down here, and then click developers. And we'll go to API keys right here. And we have our publishable key and our secret key. So copy your publishable key and keep this page up. Keep it handy. We'll use the other one in a minute. So now we'll delete this Stripe key and we'll paste in our publishable key. So now we have that. Let's come back over here to our React app and we see we have pay with card. Click on that and this pops up. Perfect. So now what we want to do, let's make this look a little bit better. So we'll give this a class name of my-3. So the margins on the y-axis be 3 units, and then we'll do btn-block. It's the same class that this button down here has. Button block just makes it stretch across the whole width. So we have that. Now let's look at our current order pizza button that we have. We can see it's a button that on click runs the submit pizza function, and then it just has color, size, and class name. So really all this button is doing is running the submit pizza function that we have, which is right here. So for now, we're just going to delete this whole button and we'll come back to that later. So right now, this will pop up, but we do not have a way to submit our pizza. So we'll deal with that once we figure out getting our token. So this Stripe checkout, it'll ask us for our credit card information, and then it will send us to this on token event. So let's just go ahead and delete everything in this on token function, except for we will console log out the token, and we'll put, so we'll name it. So we'll do quotes and we'll say token. And then we'll do the token that it gives us. So it passes the token as a parameter in this function of on token. So now let's try this out. So click pay with card. We'll type in an email, just anything. The test, you can see test mode up here. So Stripe test cards they have several test cards. The easiest one to remember is just 42, 42, 42, 42, 42 until you're out of space. And then you can put in anything for both the expiration date and the CVC. So I usually just do that and that. It's a quick way to run through it. And then you click, let's open up our inspector so we can see what our console gives us, and click pay. And we can see down here in the console, I can't make that bigger, sorry. Down here in the console, we have token, and it's an object with the ID being this TOK underscore token. And then some other information. We have the email address and the card information, not the actual card number, but information about the card. So let's switch back over here. So we know that the ID is the token that we want. We don't really care about any of this other information. So what we want to do is now we want a way to send this token to our API. So let's kind of set this aside for now, and we'll go over to our API and we'll open up our routes.js file. And this is where, if you remember, we have our all of our routes for our different API endpoints. So we have the ability to post, put, and get all the stuff for orders. So let's scroll down here to the bottom, right above module.exports, and we're going to create one more. And this will be for our checkout. So we'll type router.post, parentheses, and then we'll do quotes, and we'll type /checkout, and then a comma, whoops, a comma, and then we'll do a function. And this function is going to get request, response, and next, just like that. So anytime someone posts to our /API/checkout, remember, because all of these are mounted on the API endpoint. If we look in app, we can see that our routes are all on the /API. So /API will be before all of these when we see it in the browser. So when anyone sends a post request to /API/checkout, we're going to run this function. And for now, we just want to console log the request body. And inside this request body, we're going to pass the token. So let's switch back over here to the order page. And we can actually look in the submit pizza. We make a request to our API as well, to API/orders, and we're doing a post to create a new order. So let's copy this whole thing. So from these parentheses up through the host, let's copy this and paste it into our token on token function, and then we'll edit it as we need. So we're getting our token function right here, our token object, and we're logging that out. Let's just delete that since we already know what we're getting. And we're getting our host. And what these lines do, remember, this is just a way for it to work both on localhost where we're testing it and on when it's deployed online. There probably is a better way to do this, but for now, this will have to do. So we're going to Axios post to our host and on port 3001. So what this is doing is this is a regular expression that's just taking out the port number. So we're taking out the port number. So if it's localhost or whatever web URL it is, we can add it in again right here correctly. So we'll take out this. We have our host and then our port 3001 where our API is running, and then we'll do /API. This is saying /orders. We want to do now /checkout. Remember, because we just set up the /checkout row. So we'll do API/checkout, and we're going to pass it. Let's pass it all of these things as well, but we want to now send it the token. So we'll say token.id. So remember this token, we're passing it. The ID is, oh, it refreshed, but the token.id is where we have our TOK_ID. That's what we want to send to our server. So we're going to send it in the body of this post request, and we're going to name it token, and it will be token.id that we're passing it. And then we have customer name and size and toppings and the price. So we're actually going to need this other variable where we find the customer name from submit pizza. So we'll copy this down here as well. So I talked about this in the very first tech talk when we were setting up our API. We're not actually going to want to send the price to the server. Anytime, if you're calculating the price on the client or on the browser, that can be manipulated. So if someone knew what they were doing, they could get in there and give themselves a pizza for $0, and that would be great. So we don't want to let them do that. So we'll leave the price in there, but we won't use this at all to calculate the price. We're going to calculate the price in a different way on the server instead. So let's test this out. So we've got our on token. When we get the token back from Stripe, we're going to send this up to our API, and then in our routes, we're just going to log out what we find. So let me open up our terminal again. Okay, so we have our API. Let me restart that so that these changes will take effect. And we'll switch over here. Okay, we'll say Bryce is my name. We'll start on our order. We will, let me select some options. and we'll pay with our card, and we'll do okay. So I sent that information over, gets the token from Stripe, goes to the on token function, and then sends it to our routes, and we're logging out what we sent. So now we can see we got our token correctly, we got our customer name, we got the size, the toppings, and the price. So this is perfect. So what we want to do now is actually charge the person. So we're going to set this up. So like I was saying, we want to figure out the price first. So let's do a constant variable, and we're going to call this the pizza base price, and we'll just say $12. Now, let's say the ingredient or cost per ingredient is going to be 50 cents. And so we have our pizza base, so no matter what, the pizza will cost $12, and then every ingredient they add will be an additional 50 cents. So how we'll calculate that is we will do, we'll do another constant, and we'll say the ingredients that they want. And that will just be, remember, we're getting the request body, so request.body, and we see down here it's .toppings. So we'll do .toppings. So now this will contain this array. And finally, the pizza price will be the pizza base added with the ingredients, the length of that array, so how many ingredients they have, times the cost per ingredient. So if they have 3 toppings, that'll be $1.50 on top of the pizza base, which is $12, so $13.50, which is a little bit of an expensive pizza, but that's okay. So, okay, so that now we have the pizza price. So what we want to do is, let's go over here. We need to find out how to charge Stripe with our token that we have. So let's look up Stripe docs for Node.js charge, and boom, that first one. There we go. Let's click on that. Actually, let's not click on that. Let's go back. We can see actually the second one is specifically for how to create a charge. So let's click on that one, and we can see create a charge, and it gives us this code right here, which is nice. So first thing we need to do is inside of our server, we need to declare Stripe. So we'll come over here, and at the very top, whoops, very top, we will bring in Stripe. And Stripe is an NPM package, so you require Stripe. So what we need to do is, we'll just close the server really quick and do an NPM install Stripe --save. Run that to install Stripe, and then you put in your secret key in another set of parentheses, just like they have it. And if you're logged in, this should actually automatically put in your secret key for you. And you can see this is my test secret key. So now that this is all set up, down here in our checkout function, we want to charge them. So copy this whole thing and paste that in there. So we're going to call stripe.charges.create, and now this amount is it's in cents. So we're going to do our pizza price, but we're going to multiply it by 100 so that we can get the cost or the price in cents. So next we need to do is tell it what currency. We're going to use US dollars, so USD. And then this source is where we're going to put our token. So delete token MasterCard and instead type request.body.token. So rec.body.token, that'll be our source. And then our description, this is what shows up on the customer's statement. So we'll just put Pizzilla, pizza, and then we can say for, and then do a little plus, and let's do request.body.customer. So that will be the customer's name. And then, So this will run, and then this function right here, it says asynchronously called. This will call once, this will get run once the Stripe charge has been created. So you can see there's two arguments. There's the error and the charge parameter. So what we want to do is first we want to check if there's an error. And if there's an error, we want to do res.status. Well, we'll do res.send error. And this will send our response, send the error to our response so that our app can see what the error was. And then after that's done, we'll just return it so it doesn't continue. And if there is no error, then we will do res.send and we'll do charge. So it can see some information about the charge. I'll just delete this comment. Now, one cool thing that you can do with Express and with, well, HTTP in general is send response codes. So let's look up HTTP status codes. And we'll look at, okay, so the Mozilla Developer Network, they have a good information on what these are. So HTTP response codes are just a number that represent what happened with the response. So you can see informational responses are 100 through 199. Success is are in the 200s. Redirects are in the 300s, and then errors are the 400s and 500s. So what we want to do is we want to look in the 200s, and 200 just means a general okay. If you want to get more specific, there's some more specific response codes that you can put. Generally, a 200 is good. So let's just type res.status.send. So inside the status parentheses, we'll say, whoops, not 200. That is for all good. So we'll do down here, status 200. So we'll say res.status 200 means all good, sending the charge. If it's not good, we want to look at our error responses. So let's scroll down here to the 400s, and we will say bad request. There's a lot of different ones you can do. You've heard of 404 probably is the not found request. What 401 is when it's unauthorized. 400 is just a generally bad request, which will just let the browser know that whatever they sent or whatever happened, they did not like it and it did not work. So we'll send them a 400 and then send the error back. So now we can delete this console log as well. So now we are all done here. Let's switch back to our order page. And this Axios post, we can actually say, once it sends stuff back, we can respond to it. So we'll do that then. So first it will post, and then we're going to define a function in here. So function with the response. So if the function succeeded successfully, we can do a console.log. It worked. And if it didn't work, if it sent back an error, there's another one that we use, and it's a .catch. So we do after do .catch, and we'll type function, and we'll do error, and we will console.log error, and we'll say, and then we'll put the response out here too. Okay, so you can see we're going to post it, and then if it works, we'll run this one, and if it doesn't work, we'll run this one. And this is determined by the status code again. So if it's a 200, it will run a then, and if it's a 400 or 500, it will run a catch. So let's go ahead and test this out. Okay, so I'll go back to my main page. Rice. We want cheese, pepperoni, olives. No, we don't want olives. We want mushrooms and onions. I don't know who put olives on a pizza. Okay, pay with card. So we'll do all of the ingredients but the olives. And we will just fill this out really quick with our test data. And click pay. And if we inspect, we can look at our console. And we can see that the connection refused to API checkout. Oh, so we forgot to start our server again, or start our API. Okay, let's try that one more time. We'll pay with card. Pay, and then it sends it off, gets our token, sends the token, and request failed with status code 400. So why is this not working? Okay, this actually did not give us our status code either, or our error. So let's do this one more time. I'm not sure why this is not working. So let's log out the error and see if we can diagnose the problem here. So let's we'll restart the server really quick so we can get that console log, and then we'll pay with card again. And we'll do internet test data. Okay. So it says, let's look at this response from Stripe. So it says the resource is missing no such token. Invalid request error. Okay, the resource is missing. Okay, so you can scroll through here and see some other information that we get from Stripe. Okay, so the problem was I was using the wrong secret key. So I assumed that the secret key that it gives you over here was the right one. I was actually not logged in this browser, and so it was giving me just a generic secret key. So I've put in the right secret key over here in my Stripe, or in my routes API. We're going to restart our server, and we're going to run that one more time. So what happens is your public key and your secret key are matched together so that it creates tokens specific to your account. So if you don't have them matched up, that is going to be a problem. So let's switch back over to our Pizzilla app. We'll pay with a card and our card number. Okay, we can check for our output down here, and we get it worked, and we get our data back. So we can see our data, we have our charge. So let's look over really quick into our Stripe dashboard. If we look at payments, we see we've got Pizzilla for Bryce for $15. So that seems to have worked. So let's see if that was right, $15. So we have 1, 2, 3, 4, 5, 6 toppings. So 6 toppings times 50 cents a piece would be $3. And $3 plus the base amount of 12 would be $15 plus times 100 to get the cents. So that seems to have calculated it correctly. So now that's all set up. The only thing we need to do now is hook this back in with our system. So once it's successfully worked, once we've got confirmation that our token worked, then we need to, instead of just console logging out our response, we should actually submit the pizza. So what we'll do is we'll just call submit pizza, and then it'll come up here and run through submit pizza, just like our previous button did when we had our start order button. So let's try this from the top and just make sure this works. So we'll do Bryce, start our order. We just get the basics, pay with our card, test 13. Okay, we'll pay. You can see it goes through, and then we are forwarded to our thanks page, and then back to our start order page. And if we come over here to our kitchen, we can see that 0 minutes ago, Bryce ordered a 12-inch pizza with these 3 toppings. Perfect. So that seems to all be in order. Our tech talk last time went over Docker and deploying our Docker containers. The feedback I got from that, rightfully so, is that it's incredibly confusing to use AWS. And I agree, AWS is a beast. If you're not familiar, I'm in no way an expert on it, and I'm still pretty new with Docker itself. So I want to give you just a simple way that you can deploy your apps that's not going to be something that you'd want to use in a really heavy production environment, but it's something that you can use to at least get started and get something running. So what we're going to do is we're going to set up just a really simple instance on the simplest of web hosting providers that I've found is DigitalOcean. So we're gonna run through that, and then we'll run through buying a domain name and actually setting your site up for a domain name. So that shouldn't take too long. So let's see if we can do this. So let me just make sure I'm being recorded. Okay, so let's pull over our other browser. Okay, so what we'll do first is we'll head over to here to DigitalOcean. We'll sign in. If you don't have an account, just make an account. It's not hard. And what we want to do is we want to create a new project. So create a new project and we'll enter a name. So we're going to call this Pizzilla. And our purpose is just a class project. So we'll create a project and we don't want to move any resources. So we'll create our project and we want a droplet. So a droplet is in DigitalOcean kind of the equivalent to EC2 in AWS. It's just a small server. So what we're going to do is we're going to choose Ubuntu. 18 is fine. And we're going to be on a standard plan. We can actually scroll this down. We just want the $5 a month instance. We'll add a volume block storage. So we just want, can you go smaller? Yeah, okay. So yeah, we want just let's go a little bit bigger. Okay, we'll say we want a $10 or 10 gigabyte block storage. Format amount, all this is just kind of setup stuff. You can usually just use the default. Where do we want our droplet? We'll just do the default is in New York. Actually, let's switch it. We'll do San Francisco just for fun. Additional options, we can just leave all those out. And a SSH key is what we want. So let's create a new SSH key. This is actually going to make me create one, looks like. It's been a while since I actually set up a droplet on here. But this is great. Let's see if we can create an SSH key. So open up your terminal and just follow the instructions along here. So it says, open a terminal and run the following command. So SSH-keygen. And it will generate a public and private RSA key pair into the file which you want to save it. So it's wanting to save the files into my .ssh directory. So let's just call this one Pizzilla key. Enter a passphrase. We want to do a passphrase, no passphrase. Okay, so then it should be done. So let's check. We'll do cd users Iceland.ssh. And not sure where that put that. Let's figure that out here. Okay. So let's do that one more time. And we'll put it in /users/Bryceland/.ssh. We didn't specify the folder we were going to put it in, and we'll do Pizzilla key, and we'll just do I believe .pem is the key file name, the key file extension. So now okay, perfect. So now we have that. I'm looking over on my other screen here. We do have the Pizzilla key.pem SSH file. So what we'll do is we'll do cat to get the contents of it, and we'll do Pizzilla key.pem. Okay, and then we'll just copy this whole big thing and put this right there. And we'll name this the Pizzilla key. And we'll add the SSH file. Oh, okay. Generating, we didn't really read the instructions over here, so let's read the instructions. So you'll be prompted to save and name the key. Yeah, we did that. Next, you'll be asked to create and confirm a passphrase for the key. Highly recommended, but we're not going to do that. It'll generate 2 files. Next, add this public key. Oh, we added the private key. So what we're going to do, so we can see right here, we added pizzilla.pem. We need to add the pizzilla.pem.pub for public. So we'll do pizzilla key.pub. Okay, and perfect. We will grab all that, and let's copy that and add the SSH key. And there we go. Okay, wow, took us a minute, but we're there. So just to review, we just typed that into our terminal. We told it we wanted to put it, we told it where we wanted to put it, so we just typed the path. So I put it in my users/Bryceland or /user/.ssh, and then just gave it a name. And then we didn't put in a passphrase. And then we just copied, oh yeah, here we go, cat, and then the name of the file and the location of the file, and then make sure you get the public one, and then just copy that into this text field right here and put the name that you want to give it a name. So we named ours Pizzilla key. So now we will choose a host name. That's fine, we don't need to do that. We don't need to add any tags. We'll add it to the Pizzilla project, and we won't enable backups. So let's create our droplet here. So what this will do is this will launch a virtual server. We can see we've got a it's booting up. Let's look at okay, here we've got our 10 gigabyte volume. Okay, perfect. So now we have an IP address. So now we can actually connect to our droplet. So you can see right now, if you type in the IP address in your browser and you go to it, there is nothing that happens because we have not set this up. So first, what we're going to want to do is we're going to want to come into the Networks tab under our droplet and click Manage Firewalls. And this standard firewall may be, we'll just click on it and make sure that we have the ports open that we need. So we can see we have our SSH port open, so 22, and then we have a few other ones. Looks like this one is actually very open, all the way open. Probably not good, but that's fine. We don't really care about that for now. What you want to have open is 22 so that you can SSH into it, 80 and 443, and then also we need 3001 so that we can get to our API. So I do not have 3001, although I do have all ports. I'll just add 3001 so you can see. So add a custom down here, and then just type 3001 for TCP and click save. and we updated our firewall. So now we are allowing port 80, port 443, and port 3001 and port 22 to talk to our server. So let's come back over here, open up our droplet again, copy that IP if you don't already have it, and let's open up something like CyberDuck. If you're on a Mac, CyberDuck is a great one. If you are on Windows, Putty is a great one. So we'll click Open Connection, and this is where we can put in our stuff. So let's click SFTP and paste the URL of, or paste the IP address into server. So we're going to SFTP into this one, secure file transfer protocol over port 22, and we need a username, and our password is just going to be our SSH private key. So we'll pick our Pizzilla key, and we just need a username. So what is the username for the, I think it actually may just be root. If it's not root, then we'll try something else. Okay, it was root. So allow that, and it will boot up into our server. So now this is our server. You can see it's a typical Linux server that we're running. So let's go, I'm just kind of figuring this out along with you guys because it's been a while since I've set this specific type up. So what we're going to want to do is we're going to want to copy actually all of our Pizzilla files over into this directory, or into the server. So what we'll do is find your Pizzilla project wherever you have that. So here's mine. What we're going to want to do is open these up. We don't want to copy node modules because that'll take a few years to copy over. So I'll move that to trash. And we'll open up our API folder and move those node modules to trash. And don't worry, we can always get these running again just by typing npm install. So we'll copy these two folders into our home directory. And you can see that's going to transfer. I will make you wait for that transfer. Okay, there we go. So that's done transferring. So we can see in our server, in our home directory, we have these two great apps ready to go. So now what we're going to do is we're actually going to open this in a terminal. So we're going to open up our access to our server in a new terminal so we can start up these apps. So we'll see we have our API and our Pizzilla React. This does not have Node.js installed, I'm pretty sure. So yeah, so Node is not found. So what we're going to type apt install Node.js. And it did not work, of course. So let's look this up. Install Node.js on Linux. So install Node.js on Linux. So we'll scroll down here. Okay, maybe we just need to add a sudo in front of it. So sudo apt install Node.js. Did not work. So try the old apt.get update. Okay, so type sudo space apt-get update, and we will update our apt repositories, and then we'll type, well, it might be easier for you to just Google this. So this is the geeksforgeeks.org website. So if you just Google install Node.js on Linux and open this up, this is the recommended one. Scroll down and follow these instructions. So sudo apt-get install Python software properties. Honestly, I have no idea if this will work, but we'll get it somehow after a few different tries. Okay, package Python has no installation candidate. Who knows? Okay, we'll move on to the next one, see if this works. It's always fun setting these up. You just have to try stuff so it works. So add Node.js PPA to the system. Okay. Oh my goodness, not happy. I don't like these instructions. Let's look for different ones. Let's try specifically DigitalOcean. Perfect. Oh, look, a DigitalOcean guide. Should have gone here in the first place. Okay. We need our sudo apt update, which I think we already did, but we'll do it one more time. Okay, sudo apt update. Perfect. And then we'll do sudo apt install Node.js. We'll click Y. I thought we already did this, but I guess not. Perfect. So that appears to have worked. We'll do node-v. Perfect. We're on node 8. And we'll do sudo apt install npm. We don't have npm installed yet. So that'll run through there, install that. And yeah, perfect. So we should be good to go now that we have that installed. Okay, so this is 99% done. Come on. Okay, so this is finished installing. And if we do node-v, we can see we're on node 8 and npm-v to see that we have npm installed. So now we're in our home directory. So let's go into our API and do npm install. And this will look at our package.json, see all the things that we've installed before. So when you do --save, it saves all the things inside of these inside this dependencies object. So remember we did stripe --save, that saves it in there. So anytime you put it somewhere else without the node modules folder, you can just quickly do an npm install and it will install all those automatically. Okay, and then we'll go into our Pizzilla React folder and we'll do an npm install as well, or an npm-i. It works the same, it's just short. So once those are all installed, then okay, so it turns out there was a little error when we ran that. It should say missing required argument number 1. So what happened was the version of Node.js that they had us install through that tutorial was actually really old. They had us install version 8. We need to be running on version 12 or later. That's the recommended version. And there are some things that they had changed in these later versions that caused what we had to break. So come over here to install Node 12 and Google install Node 12 on Linux and use this first link on computingforgeeks.com. And all we want to do is just scroll down here. This is a quick fix and just, we've already done a lot of this. So just copy this curl command, this very bottom one, and paste that into your terminal like that. And that'll go through, that will download Node 12, and then just do sudo apt-y install node.js, this next one. And that should put you, once you run that, onto node 12.16. And then if you do npm-version, it will automatically update to version 6. What happened was npm actually started shipping with Node in the later versions. So when you install Node, you automatically install npm. So that's how that automatically updated. And then once you do that, run npm install again on your Pizzilla React, and it will run through just fine and install all of our dependencies. If you do happen to run into a module not found error later on, just see what the module's name is and then do npm install -- save and then type the name. So if you forgot to install Stripe or save the Stripe, then that's how you can fix that. So there, perfect. So we have all of our node modules installed. So now we can do an npm start, and this will start up our development server. We'll wait for a second to let that start up. Okay, so now that is ready to go. So if we load up our droplet again, remember it's on port 3000. So ta-da, we will see our app running on our droplet. So let's close out of that and test our API just to make sure that works. So we'll go into our API and do node app.js. And that should be listening on port 3001. Let's see if that picks that up. And we get our cannot get. So if we do /API/orders, we can see we get all of our orders, and that is working perfectly. So one thing we need to do is we need to set this API to run constantly, because right now, if we close this terminal, if we close our connection, this will exit out of all of this stuff. So what we're going to do is we're going to say we want to install what's called PM2. So we'll type npm install PM2, and that will install a process manager that will let us run this in the background. So that will install for a second, and then all we have to do is type PM2 space start space, and then we'll do app.js. And whoops, oh, you know what we need to do is npmi PM2, and we'll do -g, which will install that globally. So that will install it for our whole server instead of our project. I forgot we need to do that. So then we can see it from the command line like that. So now if we do PM2 start app.js, that will start up our PM2 server, and we can see app is running, and this gives us a great way to monitor all of the processes that we have running. So now we can see our app is still up and running. However, our terminal is free, and if we close our connection to the terminal or to our droplet and our server, that will still stay running. Okay, so now that we have our API set up and running correctly on this server, what we're going to do is we need to set up our React app. But how we've been doing it traditionally with the npm start, that's actually starting our React app in development mode. And what that means is that it's not optimized and it's not really ready for production build. So what we want to do to get it ready for our production build is really easy. All we do is we're going to run npm run build. And what that does is that it runs React scripts build, which creates an optimized production build for our app. So instead of needing to run a server to run it, it actually boils it down to just a folder that we could serve from just an Apache server or anywhere really. What we're going to do is we're going to build this optimized production build, and then we're going to use the serve module, which it'll tell us about. It'll give us some instructions as soon as this is done building. But you'll notice this is actually, if we come back over here to our CyberDuck, where we can look inside of our server, now that we've built that, you can see that actually creates a build file that inside has an index.html, has all of our media that we're using, all of our images, and this just boils your entire React app down into a folder that you could just put out onto anywhere that you can serve files from, really. So this makes it a really easy way to run a really fast production build of React. So again, you don't want to ever use just like npm start in production. You want to build it down to this production build. So now that we have that, we can see that it gives us some instructions on what we can do with this. the main one, it says the build folder is ready to be deployed. You may serve it with a static server, serve-s build. And if you don't have serve installed, it'll give you instructions on how to install serve. So we'll just do that right now. It's another global module like PM2. So we're going to do npm install, or just i-g, and then we'll type serve. And what that will do is I will go through and that will install serve so that we can then run it. So we have serve, and now we just type serve-s build. So that will do serve, and we're going to serve the directory called build. So it says, great, we're running on port 5000. So we come back over here to our droplet online, we can see port 5000, we have it running, but that's not what we want. We want it running actually on port 80, so that when we go to just our normal droplet without specifying any port, that's what shows up. So if we do, we can just do serve. Let's look and see if we can figure out how to do this. Let's do, whoops, serve dash help. And that usually gives us some information. Okay, perfect. Looks like we can specify a port with the -L option. So for listen, so -L, and then we can say what port we want. So let's try that one more time. Let's type serve-s, our build folder, and then do -L and type 80. And that's listening on port 80. Let's see if that works. And there we go. So now we are listening on port 80. And when we check, we still have our API running on the background on port 3001. So this is great. We just have one last problem, and it's that as soon as we close this, this will stop running. So we need a way to add this onto PM2. So we're going to do the same thing we did before, except now we're not running a JavaScript file. Before we did PM2 start app.js, right? We don't have an app.js to start because we need to run this whole command. So what we're going to do instead is do PM2 start, and we're going to put the command, so serve, and then we're going to do space, -- space, and this now lets us put in these extra parameters. So it'll run the serve command with these extra things. So we'll do a -s, build, and a -L, 80. So if it's not working, double check that you have build spelled correctly, and also port 80 is specified S and L. So we'll run that, and you can see now we have serve comes up. So if we do PM2 list, we can see what's currently running. And now if we just come back here to our normal site, we can see that we have both our API and our React site running correctly without any, we can actually close down this connection to the server and terminate the SSH window, and this will still work because we have that set up correctly. The last thing I want to do with you guys is just go through and look at how we can set this now up to a domain name, which is pretty easy and pretty fun. So all you need is your IP address, and you can use really any domain hosting website or web service for this. I'm going to use domains.google.com. That's just linked to your Google account. This is where I buy all of my domains, and we're just going to buy a domain right now and show you how to set it up. So they're $12 a year, most of them. So let's look up Pizzilla.com. Okay, Pizzilla.com is $12 a year, but someone already has it and they're selling it for $3,000 upfront. So we don't want to do that. So let's look for Pizzilla Pizzeria. How about Pizzilla Pizzeria? Actually, I hate that. Let's do Pizzilla Pizza. Okay, Pizzilla Pizza is available for $12 a year. No one owns it. So let's actually add this to our cart. And we will, we want privacy protection. I don't want to auto renew that because I don't want it again. This is just for fun. We'll check out. And we will buy this. Whoops, that shows my address. Okay, we register it. It just takes a minute. And you can look over here on the side. This is where you can set up a lot of stuff through Google what we want to do is we want to look at the DNS records for this. So now that we own pizzillapizza.com, we're going to use the custom Google, or we're going to use the Google domain name servers. All we want to do is we want to scroll down here to custom resource records. Come back over here, copy the IP address for your droplet, and we're going to set up an alias record, so an A, just paste in that. We'll set our time to live to 1 hour. Hopefully that'll get done quicker, it usually does. So we'll add our IP address for our droplet as an alias request. And okay, it says it'll take effect within 48 hours. Hopefully it's a lot faster than that. But that's really all you need to do to hook up your droplet to a domain name. Let's see if Pizzilla Pizza, let's see if it's already set up. Sometimes it's really fast. Okay, I'll change the time to live to be 1 minute to see if we can speed this up a little bit. I'll pause it and come back. Okay, it still hasn't loaded. It's been a few minutes. This will, sometimes especially right when you register one, it will take a minute to go through. So pizzillapizza.com is correctly set up, and that will configure over through our DNS records to point to our IP address that we have here for our droplet. So that is how you deploy your app quickly to a droplet and set up a domain name to link to it. So there you have it. This has been our Pizzilla Tech Talk series. I hope you were able to learn something from it, and more importantly, just see some technologies that you'd like to look more into. This was really just scratching the surface on all the stuff that we went over, but hopefully you got enough under your belt that you can show off in interviews and had some good experience. So thank you. Okay, just a quick edit. This finally came through, and you can see pizzillapizza.com is our React app all set up and ready to go. And if we go to pizzilla.com port 3001, we can see our API. So API orders. And again, we just set that up through the DNS records on Google Domains to point with an A record, an alias record, to our Ubuntu or to our droplet on DigitalOcean. And this works the same no matter where you're hosting it. You just point the domain name to this IP address. One other thing I did forget to talk about was how to set up webhooks in Stripe. So I just want to go over that really quickly. If you click dashboard, and then you're going to come down to, we'll look at test data again, and click on developers and webhooks right underneath API keys. This is where you can set up webhooks. So endpoints receiving events from your account. That's where you're going to set yours up. You're just going to put in the address. So in our case, it would be pizzillapizza.com/API/Stripe, or whatever endpoint you wanted to set up. So again, if we come back over here to our code, into our routes, what we would do is we would set up a new route. We do router.get, or actually post, I believe it sends. Okay, it doesn't say what it sends. So what we can actually do is we can just type any, and that will catch anything. And we'll do /Stripe function request response next. And then what we can do is just check the data from Stripe is going to be in our request.body. Actually, you know what? It is a post. So we'll change that to a post. It sends it only the post requests have body. A GET request can't have a body. So that'll be you getting your data from Stripe. So anytime you want Stripe to notify you if an account was updated or a charge failed. You can really anything in here. A customer subscription is created. That's one that I use whenever I have subscriptions in here in Stripe. I can set it up so that it will send a webhook or send a post request to this function right here. And so whatever I need to do whenever I get this data right here will be an object that has the customer ID and then information about the data. So again, that's how you set that up. And then you would just hit add endpoint and it would send it over. So perfect.